Laser engraving has become extremely popular in the last few years, and thanks to the fierce competition between the manufacturer, they become more and more affordable. In today's market, you can get one for less than £200 or $200, depends on where you are in the world. Hello, my name is Benson and welcome to my channel. Today I'm going to show you this laser engraver from ACMER. They reached out to me and want me to showcase their entry-level laser engraver, and this is what I'm doing today. So ACMER decided to send me this unit, which is the P1 S Pro. This is the entry-level laser engraver with a 6-volt laser output. It comes in a box like this. My video is not scripted, so I'm just going to do unbox and show you exactly what your money can buy. So I have no idea what is in these pieces right here. So let's go through the boxes and see what your money can buy. Now this is international shipping. I have to say the packing is up to the job. All the boxes is intact and I have seen no dent or damage in the outer boxes so far. So the first box that I open here is a material sample box. So I got a metal vase to test the engraving on metal. I got some aluminium business card. I think this is glass, square, tiles, some wooden keychain, cast acrylic sheets, and also a range of plywood. So here is the honeycomb bed, so that you can lay your material on and still got some air flow through it. It's already some plastic packs to hold down your material, which you just plugged in. And this is quite a rigid size bed with a sheet of metal material. And now it comes to the actual engraver. So again, UK plug, 6-volt is the power output. P1 S Pro laser engraver cutting machine, and this one has a machine size of 560 by 570 by 185 mm. This is the external dimension. Engraving accuracy of 0.01 mm. Engraving range is 380 by 370, which is pretty standard in today's dial laser technology. So inside the box, you got your information booklet. You got a couple of pieces of material to test. Okay, so inside the box, everything has this kind of a foam protection. And I do like the way that, you know, each of the piece has their own kind of home, so it doesn't get rattled or damaged in transit. Hopefully not. But this machine did come a long way from China. So first we have the laser module itself. Now, because it's only 6 volts, so the laser module is kind of on the small size. Look at how cute the size is. So I have a 20 or 40 volt machine before, and they are massive. So hopefully these have a smaller dot size, which is better for engraving. Plus, they have a more concentrated beam cables. Yep. So you got your 3-pin plug for the UK. You got your USB cable to connect this to your computer. You got a pair of goggles to protect your eyes. Always use protection when you are laser engraving because you only got one set of eyes. So some nuts and bolts to put the machine together. So there are individual bags which shows you the step number on there. So hopefully this is going to be an easy installation. So the basic design of this dial laser is using these aluminium pieces to make up the frame, which is one of the most popular method for X and Y XL dial laser at the moment. This is the brain of the engraver. It also has antennae for a Wi-Fi connection. At the back is a P1 S Pro, rated power 72 volt. So this is how much it will consume, not the laser output. The optical power is 6 volt. And this is the power supply. This one has the micro SD card, a spacer for focusing your laser, and a couple of zip tie and hex key. And this is the back mounting plate for your laser head module. Now these 3 pieces here is the legs of the engraver. The 4th one is actually already attached to the brain of the engraver. just in case you're looking for the fourth one. I have a stepper motor here. Since this is the first time I put together a laser engraver, which the stepper motor is actually on a separate unit like this. Usually it's already attached to one of the axle. So here a lot of assembly is already done. So the belt is already in place. The end switches has so the end switch has a tape over it to avoid damage. So a piece of rod, so a plastic to cover one of the slots on the aluminum extrude, and I think that is it. And this is it. So there is not a lot of part to put together. It should take less than 20 minutes. Now in my previous video, one of my tips and tricks for you guys for engraving, especially entry level, is that if you can't afford or if you don't want to get a honeycomb, you can use a baking tray with those drying rack. But having one of these make life a lot easier. These are just door trims, I believe. And sometimes they use these plastic things to hold it together. And this is exactly the same idea. You put your material on where you want to engrave, and then you just push it down onto the bed, which is an excellent idea. It works. A lot of people 3D print them. And previously I have used a laser engraver to cut out woods that you can slot onto that as well. I have to say this looks a bit posh, which is great. So the next part is for me to put the laser engraver together. Now I'm not going to do a tutorial or anything like that for you guys because there's already plenty on the internet. So what I'm going to do is I might do a time lapse just to show you that I am the one who putting this together and no other tools is needed apart from what they have sent you in the bag. So altogether it took me about 35 minutes to put this together, and that because I'm taking my time and doing it slowly to make sure I get everything right the first time. I do really enjoy the cable management on the X axle. The cable here is purposely long so that the laser can drop down, and this gives you enough slack. And the back here there is a trim, the plastic trim which comes with it to hide the cable inside the aluminum profile here. The top, they decided to use a plastic tube so there's no messy wire flopping around here, which is great. And you can see that when the module move out here, the wire is actually out of the way, which is great. You know what, this is cheap to implement, which is fantastic. But when it comes to this side, it does get a bit messy. So for example, if the laser moves back to the location until the end stop here, and you can see that this wire is dangling around here. Now I try to twist the wire so that it faces outwards, but if you don't do that correctly, sometimes what happens is it can go in front of the end switch here and trap the end switch, or if the laser is closer to this end, the wire tends to go inside, go to the end switch before the end switch is actually hit between the laser and the end switch. But apart from that, just twist it out of the way. I tend to find that it's not causing any problem at the moment. But it would be nice to have a chain or a cable chain on the side of this profile here. But overall, everything squared off, quite easy to put together. So here I got my computer. We already have Lightburn installed because of my other lasers. I got my USB here, which I'm going to plug it into the side. Over there, and then the power brick is already plugged into the socket, so I'm ready to give the laser machine power. One last check, everything is square and level. I'm going to put that in and then I'm going to turn it on. So the PC already detected something. Follow the instruction on the booklet here, which say start Lightburn, which I'm going to do. Create manually. And then this is GRBL. Dimension wise is 380, 370. Front left, auto home, and then you choose your chrome port. Okay, and switch is working as they should. So now this is kind of all set up and ready to go. Okay, just to show you guys what I'm doing to get the laser ready for my test burn here. So this piece of color protection lens is actually magnetic, which is a really good design. So you have a metal rod which is included at the right length. You put it under the laser head, and you want the aluminum heat sink to heat the block, and you set the right distance up and down to gauge the laser distance. Once you get to the level where you want to fine-tune the machine, you might find that this is not the exact amount, then you need to do a RAM test, but that goes beyond today's video. Every time you move the laser head, you want to make sure that it goes back to the home position. So just press the home position, it will go back to the original location because it has two end stop here. It's nice to see that even the cheapest or the most budget-friendly laser now have end switch, whereas a couple of years ago they won't include that in the deal. Now this machine is supposed to do 10,000 millimeter per minute, and then I'm going to set it minimum 1,000 because this is engraving. Okay, laser goggles on. Alexa, turn on extractor fan. Okay, so from this material test, you can see that, over here is burned through. So at 1000 speed and 100% is actually burned through. Those are just charcoal remain. So this piece of 2mm softwood, it can cut through in 1000 millimeter per minute at 100% power. But the point of this test for me is really just to find out the engraving speed. So I am going to choose somewhere in the middle. So for example, this is quite a good dark. You can never get black unless you use a chemical to treat the wood. Okay, so this took around 20 minutes. As you can see, this is the first engraving I got from this machine. Pretty easy with Lightburn. I just import the photo, pick out the middle of the setting here with the test burn, and there we go. Now without touching it, I'm going to see if I can cut this out. So I'm going to set it to, let's say, a low speed and high power, and see if I can cut this out as a square. Okay, so this is a human error. Because I got my extractor fan here, it stopped the machine from going back to 0, and that's why there is an offset of this line right here. Well, sometimes, mistake happens. I'm glad that I captured it on camera so you guys can see as well. So always go back to home, and then you can go with the cut again. So 800 with 80 power is too fast, so 600, maybe 2 passes. Let's try again. Now this is without air assist, so ideally you need some air assist to cut, but with enough power and good focusing, it should cut through. Maybe 2 passes. Yeah, I can see the light coming through from the bottom of the honeycomb, so I know that the second pass really cut through the wood. So there we are, my first engraving and cutout. Sorry about the line right here, but you know, sometimes mistakes can happen. And I can just chop it off, and I can still reuse this piece. So I'm really happy with the result so far. But obviously this is a very thin material, so you know, we need to keep testing and see what the cutting power of this machine is. But so far engraving is fine. And this is a aluminium business card, and it turns out perfect again. I can still do a bit of tweaking. For example, this is a 0.08 dot size solution of 317 dot per inch. I'm sure with a bit of tweaking I can turn the resolution a bit higher. But loads of potential right here. And I'm not talking about the figure, I'm talking about the actual quality of the engraving. Okay, so here's my second attempt. This one is double the resolution, so this is 600 something dpi. And if you put them side by side, so that's the first one, that's the first one, and that's the second one, with a bit lower power as well. So here is my acrylic test. So there is a black piece of acrylic. I'm just doing a speed and power test, just like I did with the timber or the wood. And it's nearly done. So there's some quite interesting results here. So the lightest color I have is kind of in the middle here, and then it kind of tail off when it's too powerful or there is not enough power. But it looks like here, which is 50% power at 8,000 speed, seems to be the lightest color. So let's try and engrave something. So this is my workflow. So this picture, I don't have copyrights to the photo. Basically, I downloaded it from the Facebook group. So I import it into Lightburn and just let it deal with all the editing algorithm. For example, this is using the function called tutor. Using the test grid, I'm using 7,000 millimeter per minute and 60% power. And already 11 minutes so far. Another 9 minutes to go, so the image will take around 20 minutes, which is pretty accurate, the estimate. And I have to say, so far it is looking good. So I'll attempt to engrave it and then cut it out as well. Okay, after I think 8 passes, it starts to have laser shining through the honeycomb. So hopefully 10 passes will cut through. Okay, so here is the final result. A piece of acrylic being engraved and cut by this 177 pound machine. This is just amazing value for money then. So even though it's only 6 volts, so it is kind of in a low power. But to cut this piece of acrylic, it needs 10 passes at 80%. Now I don't usually run dial laser beyond 80%, just to prolong the life of the laser. But a lot of people don't even care. But at 177 pounds, I think you can afford to run it at 100. Well, put in the comment section and let me know what you think. Do you run your laser at 100%? Since I now have the setting for acrylic, I'm going to engrave my name and do an outline and turn it into a keychain. I set out to find the cheapest or most budget-friendly diode laser there is on the market right now, and at £177 or 100 or less than $200 US, I think this is like, you know, very good value for money. It does come with the end switch, which is save you a lot of headache when you need to reposition. I still think there's room to improve in terms of naming the parts. You know, it took me about 35 minutes to put this together instead of, like, you know, some other on the internet which managed to do it like 20 minutes. Obviously I took my time to do it, so I try to do it as careful as I can, and I only need to do it once. Cable management wise, this is a lot better than some of the older lasers that I had before, especially this little conduit here. Does really work. It keeps all the wire out of the way. Unfortunately, I can't say much to this particular wire here, which is to the main unit. That you can see, this is actually at the engraving area at the moment. It would be nice if it is a chain or something to it would be nice to have a cable chain here, for example, but I think some of the more expensive models do have that function. At the moment, you can see that it doesn't have the shielding on at the moment, and the reason why it has a shielding on is because it catches the cutting bed. Now, the cutting bed has a metal frame with the honeycomb in the middle, and just now when I try to engrave aluminum cards, because it's so thin, the material, it actually falls below the metal frame. And when you try to focus, and then with this shielding on, it actually catches the side. That's why I leave it off at the moment. I mean, you don't really need the protection shield as long as you're wearing the goggles like I'm right now. The focusing rely on using a metal rod here. I personally find that troublesome, especially when you have the shielding on. Even the cutout here is not exactly to the aluminum heatsink, where you need to actually line that up with the material itself. In terms of engraving accuracy, for engraving it is really good. For a diode laser, I mean, obviously fiber laser will be a lot more smaller in terms of a dot size. As a diode laser, I think this is as good as it can get without tuning. I mean, I can actually do a RAM test to make sure my focus is spot on, and I can also like fine tune to make sure that I got the dot per inch correct to the laser dot. But to be honest with you, this is coming right out of the laser without adjustment, so I'm really pleased with that. The X and Y axle, this use 4 roller instead of 3, so it's on that side. But having 4 really make this a lot more solid. The only thing which can be better than this will be a linear rail, but I think again we will be find that in the more expensive machine. So unfortunately, that's all I have time for this video today. I promise there will be another few videos to come because I still have a few more material to test. For example, I want to test the machine engraving on slate, on glass, and on metal. I think I will plan a video sometime next week for that. So don't forget to share, like, and subscribe to my channel if you want more of this kind of content. But in terms of this afternoon, I'm quite pleased with the result. So aluminium card, this one is about 600 dot per inch. Still a bit of work to do in terms of getting the focusing right, but in terms of engraving picture, so you can already do that out of the box. This one here on the aluminium card, I'm using 6000 speed, 30% power, and 0.08 dot size on this one, but 0.06 dot size on this one, so this would have a slightly higher resolution. And this is a engraving which I done with Lightburn, and I remember this one, I think I used 6 or 7,000 millimeter per minute and around 60 or 70% power or something like that. I still need to tune it. If you want engraving with more details than this, then you might want to treat the wood with like a boric acid solution or something like that. You can see a line here which I captured when I was doing the cut that I made a mistake. Although this one have an end switch, but if you have something obstructing the homing and then it get out of alignment, that's why it didn't start where the image is supposed to start. But otherwise, for example, if I show you the acrylic, now this one come out really nicely. So for example, the engraving of this image right here, so this one was run at 8000 speed, 80% power, and 0.06 dot size for the engraving. So this one have a nice texture engraving on at the moment. And then it was cut by using a slower speed and high same power. So this one was cut with 800 speed and 80% power. About 8 passes and then it will cut through. The edge is very clean. There was no melting or resolidifying with the main piece or anything like that, so it comes out straight. And with this particular piece, I engrave first, let it go home position, and then I run again 5 passes, and then it go on home position again, so it didn't cut through. So I gave it another 5 passes, so it actually moved from home position to the cutting position a few times, and each time it goes back to where it's supposed to go. So I know this kind of stepping motor and the setup is correct, and I'm quite impressed with that accuracy. And finally, my little project for myself today. So my name engraved using a Lightburn simple offset function. You can cut and engrave at the same time, and I also have a hole here so that I can attach a keyring. So this is my little keyring made with this laser. And this piece of acrylic is measured 2.6 or 2.5 mil. So I have to say thank you very much for ACMER for sending me this machine. I promise you guys that there will be more videos to come to showcase what these products can or cannot do. I can't wait to see you next time with more interesting gadget. Bye bye.